Welcome to Chapter 2. In this chapter, we will be taking a lot of time with angle pair relationships, and we're going to kick that off today by looking at complementary, supplementary, and vertical angles. It says in Chapter 1, you compared shapes by looking at similarities between their parts. For example, two shapes might have sides the same length or equal angles. In this chapter, you will examine relationships between parts within a single figure or diagram. Today, you will start by looking at angles to identify relationships in a diagram that make angle measures equal. As you examine angle relationships today, keep the following questions in mind to guide your discussion. How can I name the angle? What's the relationship? And how do I know? Let's go ahead and start by talking about naming angles. In this first triangle, if I wanted to reference this angle at the top here, angle A, I could simply go ahead and call it angle A. I would use the angle symbol and go ahead and put the letter A there that represents the vertex. In the second triangle, what I've done is I've taken triangle ABC and I've kind of rotated it. I've created a second one, triangle A, B prime, C prime, and I've rotated it. Now if I want to reference the angle at the top of that triangle, angle A, I have to be more specific because as you can see, there are 6 different angles whose vertex is at point A. So as such, I need a more specific way of naming angles when I have some overlapping angles in the diagram. So instead, if I want to talk about the same angle that I talked about in the first triangle, I would have to name that angle BAC, or I could also call it angle CAB. Now in the third diagram, I have marked that the two angles are congruent. They have the arcs with the slash in it, so that is indicating that those two angles are congruent. Go ahead, take a minute using this naming convention. Which angle must be congruent to angle BAB prime? All right, now that we know how to name angles, we're going to take a look at 3 special angle pair relationships. The first is complementary. We say two angles are complementary if their sum is 90 degrees. In this diagram on the left, angle ABD is a right angle, then angles ABC and CBD are complementary. If the measure of angle CBD, that little M stands for measure of angle CBD, is 76, what is the measure of angle ABC? Another special angle is 180 degrees. If the sum of two angles is 180 degrees, then they are called supplementary angles. In the diagram at right angle, LMN is a straight angle. So if the measure of angle LMP is 62, what is the measure of angle PMN? The next angle pair relationship we're going to look at is vertical angles. When two lines intersect, the angles that lie on opposite sides of the intersection point are called vertical angles. For example, in the diagram, angle AED and angle CEB are vertical angles. Find another pair of vertical angles in the diagram. In this case, it looks like angle AEC and angle DEB are on opposite sides of the intersection point. Now considering the diagram again, if X is 23 degrees, find the other 3 angles, show all work. Well, I know this diagram is formed by intersecting lines, and I know straight angles make 180 degrees. So if X is 23 degrees, it stands to reason that I could find the measure of angle DEB by taking 180 minus X. And then once I get my answer for DEB, I'm then going to look at CEB. So again, I would do 180 minus whatever I got for DEB, and I would get 23 then when I subtract 180 minus 157 for angle CEB. Then I would repeat the process to find angle AEC, which would again be 157. Travis noticed that the vertical angles in the parts of the last problem had equal measures and wondered if other pairs of vertical angles also had equal measures. So we're going to look at the same diagram, but instead we're going to say X is 54. So I want you to go through and find out first what the measure of angle DEB is. And then I'm going to go ahead and figure out what the measure of angle CEB is. Again, I have a straight angle because of my intersecting lines, so I know that the measure of angle DEB, or 136, plus the angle I'm trying to find has to equal 180. So when I do 180 minus 136, I get 54. This verifies my conjecture, based on your observations, that vertical angles are congruent. We can actually go ahead and prove this conjecture. Do we think it's true for any pair of vertical angles? We can write a convincing argument. So I'm going to look at this argument and I'm going to say, all right, I know A plus B equals 180 degrees because they make a straight angle pair. I also know that A plus C equals 180 degrees. Well, if two things are equal to the same number, then they must be equal to each other. So since A plus B equals 180 and A plus C equals 180, I know that A plus B must be equal to A plus C. Then I can just go ahead and use some algebra to simplify. I'll subtract from both sides, and my result is that B is equal to C. If I look at my diagram, B and C are vertical angles. Since this is proven to be true, it is referred to as a theorem, proving that vertical angles are always congruent. Change this conjecture of an observation that we made into something that we have proven, and now we can use that in later problems without needing to prove it again. So again, we're going to keep practicing with these angle pair relationships. In the second one, we are going to look at another special relationship that guarantees equal measure. I'm going to give you a quick minute here. You can go ahead and pause the video, but I want you to go ahead when you're ready, press play and answer the questions for each angle pair relationship below. Decide whether the angle relationships are the same and have equal measure, whether they are complementary and have a sum of 90, or supplementary and have a sum of 180. Now we're going to start looking at parallel lines. A line that crosses two or more other lines is called a transversal. In this diagram, my transversal is given by the line JK. The parallel lines are my top and bottom lines, my LM and NP. I know they are parallel because they are indicated so by the arrows on the line. So we're going to watch this animation here. It says trace X on tracing paper and shade its interior. Then translate X by sliding it up along the transversal until it lies on top of another angle and matches it exactly. Which angle corresponds with X? Well, the angle that it matches perfectly with is angle B. So in this case, at angle X and angle B are called corresponding angles because they're in the same position at two different intersections of the transversal. Another way for me to describe that corresponding angles to you would be to go ahead and put like a plus at each intersection. Angle B and angle X are both in like the upper right-hand quadrant of that plus sign. They're in the same corresponding position. What is the relationship between the measures of angles X and B? Must one be greater than the other, or must they be equal? Well, in this case, they have to be equal because when I did that translation, the size of the angle didn't change and it matched up perfectly with angle B. So X and B are equal. All right, so here I'm going to practice identifying other parts of corresponding angles. And again, I'm going to go ahead and put that plus. I already know that B and X are corresponding angles. They are both in that upper right-hand quadrant. They are both above the parallel line and to the right of the transversal. When I look at angle A, that's my top left quadrant. That would correspond to angle W, also the top left quadrant. C would correspond to Y. They're both the lower left-hand angles. They're below the line and to the left of the transversal. And similarly, D and Z would be corresponding angles. Suppose angle B is 60. Use what you know about vertical, supplementary, and corresponding angle relationships to find the measure of all the other angles in the diagram. So looking at this, B and X are corresponding, so I'm going to know that X is also 60. But then I also know that B and C are vertical, and I know vertical angles are congruent. I know X and Y are vertical, so that is also the same. And that makes sense because C and Y are corresponding. They should also be equal. And then the only other angle measures I have left to find are these A and D and W and Z. Well, I know A plus 60 here has to make a straight angle pair. So I'm going to do 180 minus 60 to get 120. But then I know that A and W here are corresponding. And A and D would be vertical. And W and Z would also be vertical. Okay, so that's a brief introduction to corresponding angles. You will do more to investigate when corresponding angles are equal, maybe when they're not equal, or if they're always equal. We'll look at that in class. Thanks for watching.